Baik, Assalamualaikum warahmatullahi wabarakatuh. So we are in the part 2 of the queuing system, right? So the first video mentioned or discussed about the introduction about the queuing system. What is a queuing system? So we have five theories of the queuing system: the basic single server, the constant switch time, basic calling population, and basic finite calling population, and finite queue line, and we'll have so the multiple server. Okay, so for this video, actually, for the first theory, so the first theory, the first theory known as a basic single server. Okay, sorry. So the first video consists of the chapter or the discussion about the basic single server, the theory of the basic single server. So as I mentioned to you, we will have about 7 theories or 7 applications or 7 equations. So here we have an 8. Why? I will explain to you later. So in the basic queuing system, what we need to find or what we need to calculate. Okay, we have 8 things, 8 criteria that we need to calculate. Okay, the first one, the probability. If you can see the word here, most of the equation are related with the probability. That's why earlier I mentioned to you, we will use the statistical analysis or statistical theory. So which is the probability? What is a probability? Okay, probability means kebarangkalian. So when we are talking about the probability, your answer must be between 0 to 1. Okay, your answer must be between 0 to 1. Maximum number is a 1, minimum number is a 0. Your answer must be between that range. Okay, that's why here the probability. So you can see here all the word is a probability. Okay, what we need to find or what we need to calculate in basic single server or in a uniform or in a general, in the basic, in the queuing system, what we need to calculate. Okay, 8 criteria we need to calculate. The probability no customer in the queuing system. What is the probability no customer in the queuing system? Or if you apply in production floor, so what is the probability no product in the machine? Machine work. Okay, product is a client. So if you apply in the bank, bankers, so no customer. What is the probability no customer in the system? If you apply in ATM, what the probability no customer in the system? You apply in the pump station, what is probability no customer in the system? Okay, the equation, the first equation, the probability no customer in the queue system, the short form is a PO or P0. Probability, P is a probability, 0 is a no customer. So P0 equal to lambda over mu. Sorry, P0 equal to 1 minus lambda over mu. What I said in the previous video, the most important thing is lambda, the arrival rate, mu is the rate per hour. Okay, to calculate the PO, 1 minus lambda over mu. Okay, so what is the probability n customer in the queuing system? Okay, what is the n? N can be a 2, 3, 4, 5, 10 or more. Okay, what is the probability that n customer in the system? So the formula is a P and probability n equal to lambda divided by mu, arrival rate divided by switch rate, power of n. Okay, power of n equal to P, and how many number we need to define. Okay, and time with the PO. Okay, the answer we get in the PO time with the lambda over mu power of n. You will get the probability n customer in the system. Okay, the average number of customer in the queuing system. How many customer? When we observe the situation, how many customer in the currently in the queuing system, the symbol is L. Okay, the equation for the L is lambda over mu minus lambda. Okay, the average number of customer in the waiting line. We have a server, we have a waiting line. Okay, for the criteria number 3, L we cover all. How many customer in the queuing system? L. Okay, for the LQ, only in the queuing line. Okay, this is criteria number 3, and criteria number 4 is a number. Your answer must be number. Can be more than one. This is the number. Okay, so LQ number, or the average number of customer in the waiting line, is the formula is LQ equal to lambda squared divided by mu time 1 minus mu minus lambda. Okay, this criteria number 3 and criteria number 4 is numbers, can be more than one. Only the probability must be in the range 0 to 1. So the average time customers spend in the queuing system, W. Average time customers spend in the queuing system is W equal to 1 minus lambda. Well, 1 over mu minus lambda. Okay, this is the average time. Your answer, the unit must be in hour. Okay, the unit must be in hour. Why? Because lambda and mu, the rate per hour. Your unit, your answer, the unit must be in hour. Okay, so the average time customers spend waiting in the queuing to be served, that means only in the waiting line, WQ. Okay, WQ lambda over mu time mu minus lambda. Okay, same thing for the criteria number 5, the unit must be in hour, or later you can convert into the minute or second. It depends on the situation. But when you get the answer, your first answer, the unit in hour. Alright, so the probability server is busy. Server is busy is U. What's U? U is a utilization. Okay, server is a busy, lambda over mu. Okay, the probability server is either either 1 minus mu, or I equal to PO. Same as a theory number 1. Is criteria number 1. So 1 equal to I equal to PO. That's why I said you must remember 7 formulas. Okay, let's see as a first example. The fast shop market collect data to improve the customer service in the counter. Based on data collection, average arrival is 24 customer per hour. What is this? This is lambda. Okay, service rate 30 customer per hour. What is this? This is mu. Okay, lambda and mu, and calculate everything. The probability no customer in the system, the probability 3 customer, this is n customer, 3 customer in the system, average number of customer in the queuing system, average number of customer in the waiting line, average time customer spend in the total queuing system, average time customer spend in the waiting line, probability the server is busy, and probability the server is idle. Okay, lambda 24, mu is 30. So calculate everything. Alright. The customer in the system is a PO PO equal to 1 minus over mu 1 minus 24 over 30. Your answer is at 0. Mention to you, this is probability. So that's means your answer must be between 0 to 1. So your conclusion, you must put here what is your finding. The probability no customer in the queue system is 0.2. Okay, what is the probability 3 customer n? We are using Pn. Now is a P3. P3 equal to lambda over mu power of n. Lambda over mu 24 over 30 power of 3. Because of 3 customer times 0.2. What is 0.2? 0.2 is a PO. Okay. So what is a PO? PO is 0.2. So the answer is a 0.1204. So your conclusion here, the probability 3 customer in the system is a 0.1024. Okay. So the average number of customer in the queue system L equal to lambda mu minus lambda 24 over 30 minus 24 for customer in the system. Okay, the average they have in the system is a 4 customer in the system. So LQ, the number of customer in the waiting line, LQ equal to lambda squared divided by mu times mu minus lambda 24 squared over 30 times 30 minus 24. Your answer is 3.2 customer. Okay, 3.2 customer on the average in the waiting line. So every solution you must conclude. In the exam, if you are not conclude your finding, I will deduct your mark. Okay, so the next one is the average time customer spend the two total queue line. W equal to 1 over mu minus lambda. So your answer here is here the unit is hour, 0.167 hour. Okay, so if you convert to minute, you times 60. Okay, so equal to 10 minute average spend in the queue per customer. WQ, average customer in the spend into the queuing line. So WQ, your answer is 0.1333 hour, or times 60 is 8 minutes. Okay, so the probability the server is busy, lambda over mu is 0.8, I is 0.2 equal to PO. Okay, so this is the example, and let's see another example. Okay, example, this is in the practice in the production floor. You have 4 processes: soldering, insert part, testing, inspection. So the company has doing this process. So this sequence I have cycle time 2 minutes, 2 minutes, 2 minutes, and inspection is 1 minute. So sequence due to high cost of the inspection process, you want to focus into the inspection process. Okay, so management want to collect the data. As an engineer, you must collect doing the queuing analysis. So calculate everything. The probability no customer in the system, average number of what is customer here? Customer is the component, the part. Okay, why is the server? Server is the process. Okay, so every time the customer calculate everything, LQ, WWQ, PO, PN, and I and U. Okay, how to calculate? What is lambda now? Okay, what is mu? We focus at the inspection process. The mu is a cycle time is 1 minute. So that means mu is 60 minutes divided by 1. So mu is 60. What about lambda? Lambda for this process, that's mean the before of this process, the product will be arrived. So this product will be arrived from the testing. Okay, what is lambda here? How long product will be arrived? Okay, so product will arrive every 2 minutes. So lambda equal to C divided by 2. Okay, 60 divided by 2, that means lambda is 30. Okay, and complete everything. Thank you very much, and see you.